morning all of you. Hope all are doing well. In the previous class, we learnt union, intersection and difference of sets and their properties also. And in today's class, some more properties we are going to learn, mainly distributive property. Then after that, De Morgan's law. De Morgan properties also is there in sets. What are those we are going to learn. Then after that, some properties over cardinal number of sets. So these three things. After that, exercise problems. The first, properties of operations on set. In that one, distributive property. So distributive property, distributing equally. So in number system, we know distributive property as A into B plus C is equals to, in number system, not in sets, in number system, the distributive property we know as A into B plus C. If A, B, C are any whole numbers, any integers, whatsoever. Let us assume A, B, C are whole numbers. Then A into B plus C is equals to A into B plus A into C. A will multiply the whole. That means A will multiply B plus A will multiply C. So that only. So A is equally distributing here to B and C. That is called distributive property in number system. Same thing we were applying for sets also. In that one, two types of distributive properties here. So union over intersection and intersection over union. That means A will distribute to A to B and also A will distribute to C. That means A union whole. What is in the bracket? Total. A will distribute to each and every. Suppose A intersection D, intersection E, intersection F is there, then also A will distribute each and every set. That means A union B, A is distributing to B. And next, what the symbol here? Intersection as it is. A union C, A is distributing to C also. And same like that. A intersection B, A is distributing to B first of all. What the symbol here write as it is? Union. Next, A is distributing to C, A intersection C. So these two types of distributive properties are there in sets. The first, union is distributive over intersection. Intersection is distributive over union. That means A union B intersection C is equals to A union B intersection A union C. And the second one is A intersection B union C is equals to A intersection B union A intersection C. So these two properties will come under distributive. These things we have to remember. Next again, De Morgan's. Next, De Morgan's law. So De Morgan given these laws to sets. That's why we call these laws as De Morgan's laws. So under these De Morgan's law, two statements are. The first one is, if A and B are two sets, then De Morgan's law states that A union B whole dash is equals to A dash intersection B dash. The second one is A intersection B whole dash is equals to A dash union B dash. So these two laws are called De Morgan's law. So we will verify whether these two are true or false. The first example I have taken as one U, set U, set B, and set A and set B. U means universal set. I have taken under universal set the elements as 1, 2, 3 and so on up to 20, and set A as 5, 10, 15, 20. That means multiples of first 4 multiples of 5, then after that first 5 multiples of 4, 8, 12, 16, 20. So now we will check the first law. What is the first law? A union B whole dash is equals to A dash intersection B dash. First take LHS is A union B whole dash. Find out first A union B. A union B. Then after that dash. Whole dash. Whole dash means complement. Its complement means we have to subtract from universal set. That is the complement of the set we know that. So A union B. A is 5, 10, 15, 20. Union B is 4, 8, 12, 16, 20. Union means we have to join all the elements of a given sets. If any element is repeating, we have to take into count once only. So that means in order if 10 means we will get 4, 5, 8, 10, 12, 15, 16, 20. 20 is 2 times repeating. I have to take once only. Next, it is A union B. A union B whole dash. It means complement of A union B means from mu we have to subtract these A union B elements. Mu is 1, 2, 3 and so on up to 20 minus A union B. A union B means 4, 5, 8, 10, 12, 15, 16, 20. That is equals to. So minus means I told we have to subtract this element, the second set elements from set A. Remaining elements of set A, the first set we have to write as it is. Second set elements we have to subtract from first set. Whatever the remains in the first set we have to write as it is. That is the difference. That means 1 not there write as it is. 2 not there write as it is. 3 not there write as it is. 4 just eliminate that one. 5 yes. Next 8. 6 will be 7. 8 remove that one. 9. 10 remove that one. 11. 12 remove that one. 13. 14. 17. 18 and 19. So this is A union B whole dash. So up to now the first law LHS A union B whole dash we got as 1, 2, 3, 6, 7, 9, 11, 13, 14, 17, 18 and 19. Now RHS. What is RHS? In the first law only we are checking first law. LHS we got A union B whole dash as 1, 2, 3 and so on. Next, coming to RHS, A dash intersection B dash. That means first find out A dash. A dash means the elements which are not in the A. A is here 5, 10, 15, 20. Then remaining all elements will comes under A dash. That means 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. So these are all A dash elements. Next B dash. B dash, what the elements are there? 4, 8, 12, 16, 20. Only remove those elements from U. Then the remaining elements will come under B complement. That means 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, 14, 15, 17, 18 and 19. Now A dash intersection B dash. Common elements in these two. Common elements. So 1, yes, write down 1 is common element. Next 2, yes, here also to write down 2. Next 3, here also 3 write down. Next 4, not there, leave it. Next 6, yes, here also 6 is there, write down. Next 7, here also commonly. Next 8, here 8 not there, leave it. Next 9, common. 11, yes, here also 11 write down. Next 13, here 13, here also 13 write down. Next 14, here also 14. Next 16, 16 here not there, leave it. Next 15, here 15 not there, leave it. And next 17, yes, commonly. 18, so in the both sets 18 is there, write down commonly. And the next 19 here also 19. So now we check A union B dash. What the elements here? 1, 2, 3, 6, 7, 9, 11, 13, 14, 17, 18, 19. So in A dash intersection B dash, the elements are 1, 2, 3, 6, 7, 9, 11, 13, 14, 17, 18, 19. Both are same. That means we can say A union B whole dash is equals to A dash intersection B dash. This is the first De Morgan's law. By taking example, we can prove. And the second one also, take the same example and you may prove. And the next cardinal. So here are the most important cardinal numbers, cardinal number properties of sets. And simply we can say cardinal properties of sets. So upon these properties, even we can get in 10th class level questions also. That means in 10th class board examination, on these 6 cardinal properties, frequently we are getting questions. So that's why it is the most important topic, cardinal properties of sets. So we have to remember these properties. And in worksheet, today's worksheet, so I will give mu, that means universal set, and set A, set B. By taking those sets, you have to prove these are all. So that is a worksheet work I will give today. So let me explain these cardinal properties. The first one is if A and B are two sets, any two sets, then n of A union B, that means number of elements in A union B is equals to n of A plus, that means number of, n means number of, cardinal number like that only will represent. So already we discussed these things of cardinal numbers, how to represent what is cardinal number. So the first property, n of A union B is equals to n of A plus n of B minus n of A union B. N of A union B is equals to n of A plus n of B minus n of A intersection B. Next, if A intersection B are disjoint sets, that means no any common element in A and B, then clearly A intersection B is fine, no any common element. The number of elements in A intersection B, 0, nothing will be. If A number of n of A intersection B is 0, then A union B is equals to just n of A plus n of B minus 0 means just remain n of A plus n of B. Why? Because n of A intersection B is 0. When A and B are disjoint sets. Disjoint means no any common element. Simple to remember. First one is n of A union B is equals to n of A plus n of B minus n of A intersection B. If n of A intersection B is 0, then n of A union B is equals to n of A plus n of B. And the next, third one, n of A minus B, that means the number of elements in A minus B is equals to n of A union B minus n of B, or as well as it is equals to n of A minus n of A intersection B also. Next, fourth one, n of B minus A, that means number of elements in B minus A is equals to n of A union B minus n of A, as well as it is equals to n of B minus n of A intersection B. By taking example for A and B, we may prove all these. Next, n of A union B, that means number of elements in A union B is equals to n of A minus B plus n of B minus A plus n of A intersection B. Next, the last one, if universal set U is finite, that means limited numbers. And A is any set, then we can say n of A plus n of A dash is equals to n of U. Simple. Take universal set as 1 to 10, n of A as 1 to 5, then n of A dash 6 to 10. That means how many? 5 elements in n of A. 5 elements in A, 5 elements in A dash. So n of A plus n of A dash is equals to 10. That is equals to n of U. Very simply we can prove all these cardinal properties of sets. And the next exercise problems will start on these topics. So we discussed today some properties. What are those? Distributive property and De Morgan's law. Then after that, cardinal properties of